Hello, and thank you for attending the EagleAR Virtual Critical Design Review. The EagleAR team presenting today consists of Lucas DeLong, Alexander Erno, Sabrina Nunn, Reagan Sensmeyer, Elizabeth Sechting, and Yuri Terletsky. The goal of this design review is to discuss the purpose, design, and creation of the EagleAR application. We will also demonstrate a prototype of the team's development progress and discuss future steps for the application. This presentation will address the following topics. We will begin with an introduction to the EagleAR product, its intended users, as well as the overall application design and development plan. We will then discuss the testing and deployment process for a mobile application, and will end the presentation with the challenges we faced, the project management approach taken, and a final administrative update that will include a series of next steps that could be associated with future versions of this project.
Over the next few slides, I will be covering a brief summary of the product, what the product will do, and some of the benefits that this team believes it will have on its intended audience. We will also cover some of the diagrams associated and review a scope of the system. EagleAR is a language learning application which integrates the active features of augmented reality, or AR, and language comprehension. This application was created for Dr. Zan of Embry-Riddle Aeronautical University's Department of Global Security and Intelligence Studies. Augmented reality, or AR, is the overlay of digital objects onto the physical world, and with this there are three different types. Marker-based AR is a form in which the virtual objects are tied or anchored to physical objects. A great example of this would be the Google Translate application, which displays translated virtual text over physical text in another language. The second is markerless AR, and that is a form which is similar to marker-based, but rather does not tie the virtual objects to specific targets or anchors. Instead, these virtual objects are free to be moved around virtually. A good example of this in action is the IKEA app, which allows a user to view a virtual object around their surroundings and gives that user the ability to move the object around to their desire. Lastly, location-based AR is a form with which virtually displayed objects appear depending on the location of the device. A really great example of this in action is the popular mobile application Pokemon Go. With this app, a user travels around and can view creatures depending on their location. Moving on now, there is a plethora of styles available to students for them to determine what method or methods work best for them to succeed in their learning. With this application, we believe that we provide an innovative style of learning, especially when it comes to learning a language. With our application, we include features like physical interaction with users surrounding by use of augmented reality, or AR. Physical interaction has especially been proven in studies to benefit those with learning disabilities, as the movement helps to create a link to what they have learned.
The entire product will consist of a mobile application and a website application. The mobile application will be where the users can participate in the gameplay associated with their course. On the website application, we will have information regarding the mobile application, as well as the ability for admin and professors to manage the gameplay content located on the mobile application. This is the block diagram for our system. On the left, you can see the admin or professor user is going to interact with our website user interface. Now, this website used to be hosted on GitLab pages, but that is going to be transferred to a Pluto server, which will be more easily accessible by members of the REU faculty and student body. That website is going to interact with the course content, which will be stored on Amazon Web Service data storage. On the right, we have the student user, which interacts with the mobile application user interface. This will be a cross-platform application, so it will be available for download on both iOS and Android devices. This application will interact with user data, which includes localization data and internet access that is found through the user's mobile device. And this data will also be stored on the Amazon Web Service data storage. This is a data flow diagram of our system that shows how the mobile application and the website application interact with each other. So on the left, we have the mobile application, and there the user's data will be collected and sent to Amazon Web Services to be stored. This information will then be accessed and accessible to the admin and professor users on the website, which is currently on GitLab pages, but will be moved, as explained before, to Pluto. This website will then be where admin and professors create the course content for the mobile application, and that course data will be sent to Amazon Web Services to be stored and then accessed by the mobile application to be integrated into the gameplay. All the information we've given you so far has been about the system as a whole, but for the scope of this project, we're just going to focus on completing the minimum viable product. The minimum viable product includes making a cross-platform mobile application that has local data storage. Now, this application is going to have very simplistic gameplay, which will include a basic point system, the ability to find AR objects on the map, have those AR objects be location dependent, and then the user must have the ability to interact with these AR objects. On top of that, we will also implement a very basic website. Here is a modified system block diagram that shows which sections of the block diagram are included in the MVP and which aren't. On the right, in the green, and on the boxes that are colored green and enclosed in the green box, are all parts of the system that will be included in the MVP.
Next will be an overview of each of the application's user types. EagleAR features three distinct user profiles: the student user, the professor user, and the administrator user. The most essential of the three is the student user, considering it is the only one which is part of the MVP. Students are students enrolled in the Chinese language courses at Embry-Riddle Aeronautical University, and each of their abilities will be elaborated on in later slides, but just to name a few for now, some of their abilities include registering for classes, taking quizzes for those classes, and interacting with the gameplay map, and they perform their abilities with the use of the mobile application. Next is the professor user. Professors are the instructors of the courses which the students are enrolled in, and some of their abilities include uploading content to courses, modifying a course's roster, and viewing the statistics for each of their classes. And they perform their abilities with the use of the web application. Next is the administrator user. Administrators are trusted users which manage the overall application, and in addition to having all the same capabilities as professors, and they perform their abilities with the use of the web application. So next is an overall use case diagram of the application. It is slightly simplified for the sake of readability. For example, it doesn't include the professor having to log in before performing their use cases, but it is simply meant to give you an overview of how users interact with the application. The use cases in green are those which are part of the MVP, the ones in blue are not part of the MVP, and the ones in yellow have a basic implementation in the MVP and will be expanded upon at a later date. And I'll give you a moment to look at it. Next is a use case diagram for the student user. Upon opening the application, students have a few options. They are creating an account, logging into an existing account, and resetting their password. Once they have logged in, then they are able to proceed with the rest of their abilities, which include taking a quiz, registering for a class, and managing their settings. This diagram has the same key as the previous slide, where the ones in green are part of the MVP, the use cases in blue are not part of the MVP, and the ones in yellow have a basic implementation in the MVP and will be expanded upon beyond it.
In this next section, we will discuss some of the details related to the design of EagleAR. In this first slide, we'll cover the user interface for the mobile application. For the mobile application, we decided to make the user interface a Windows, Icons, Menus, and Pointers type interface, or WIMP. The user navigates through the menus and interacts with the application using the touchscreen. This interface scheme was chosen to provide an effective and intuitive user experience. The user interacts with their course content through the use of augmented reality using the device camera. An example of the user interface and augmented reality functionality will be shown later on in the demonstration slides. In this slide, you can see a list of all of the epics for this project. The list is color-coded to reflect whether each epic was in scope for our development this semester or not. In yellow are epics that were required for the minimum viable product, which are the map and gameplay. In blue are epics that were required to be partially implemented for the minimum viable product. These are the web application and the point exchange. Lastly, the epics in gray are those that were out of scope for our development this semester. These include account creation, tutorial, login, account management, feedback, and classes. The map epic consists of a map of the ERAU Prescott campus for the users to move around in and access course content through different points of interest. The user's location on the map is tracked using their smartphone's localization data. The location information is used to detect if the user is close enough to a point of interest to interact with it, or if they have left the bounds of the game. The boundary of the game is Dover-Team Road around the perimeter of campus. The map will be seen in action later on in the demonstration slides. The gameplay consists of the user moving around the map with their smartphone until they reach and activate a point of interest. They will then be transitioned to a quiz that will test the user's vocabulary on a topic related to the location they are at. The quizzes use augmented reality to engage the user in the scenario and provide visual stimulus and feedback. An example of this will be shown later in the demonstration slides.
The web application exists to satisfy both Apple and Google Play Store development requirements and contains a basic description of the application, all developers' contact information, and a privacy policy which adheres to International Review Board standards and is also a requirement by both Apple and Google Play Stores before app publication. The point exchange feature of this application allows student users to gain or lose points from activities during gameplay. As a student takes quizzes and interacts with the AR content, they can gain or lose points based on their performance. As it is currently implemented by our team, a student user can gain 5 points and lose 4 points based on their performance. The accumulation of points will eventually allow a user to level up to the next module after a successful completion of their current module. This creates an incentive for the students to continue playing the game and to progress through the modules as they progress through the class.
The EagleAR design follows a role-playing game storyline, where the user's avatar in the application is an assistant on the Embry-Riddle Prescott campus. Their goal is to complete tasks associated with their job, such as ordering coffee, helping give directions around the school. The interactions that the user has during the gameplay will follow that basic storyline. There will be a series of levels that correspond to the class content modules provided by the professor. Each module will have a set of tasks with associated vocabulary and language content. When a task is completed by correctly answering a question during the augmented reality portions of the gameplay, the user will earn points. With enough points, the user will be able to take an assessment quiz and level up to access new course-related content in another module. The user can then play the new module's tasks or go back and practice the content from previous lessons. This flowchart depicts the basic flow through the application that the user will take. A user will begin by either logging in or creating their account. Once successfully logged into the application, the user will view their location on the map. From there, the user can use the map to navigate to a point of interest and view the associated augmented reality object. This is where the story-based tasks will occur. The user will be prompted with a task and a question. If they properly answer the language question, the interaction is considered successful and the user will earn points. If the user is incorrect, the interaction was not successful and the task was not completed. The user will lose points. From there, the user can continue to locate points of interest and interact to answer questions.
Now we will go over the development plan. The development environment we have selected was Unity Game Engine. Within Unity, we have added 2 add-ons called Mapbox and AR Foundation. Mapbox enabled us to use localization with the character, so we were able to track whether they are within a point of interest. AR Foundation has helped us use cross-platform AR or augmented reality functionality. It automatically exports the code whether to iOS, which would be the AR kit, and to Android, which is AR Core. In order to use our development environment, we had two required software kits, which is Xcode for iOS and Android Studio for Android. And since we used the Unity game engine, this enabled us to use the C# language, which is built to help game development. We have planned to support two operating systems. First is iOS versions 11 through 13. Second is Android versions 7.0 to 10.0. But due to some obstacles and difficulties that will be discussed later in the presentation, iOS deployment may not happen. Next, we will be moving on to development progress. This is our scene integration chart. First is the home or start scene. This scene was supposed to help with the account creation or login scene, but since that has been taken off the MVP, we have just a simple click to start scene. When that button is clicked, it'll go on to the map scene. The map has points of interest embedded into its scene. When the points of interest are interacted with, it'll move on to the AR view scene. The AR view scene has content that could be interacted with, and once the content is interacted with, it'll move back to the map scene.
The points of interest that have been implemented in the application are listed here. Next to each location is listed a topic of vocabulary to be covered there. Each point of interest vocabulary topic is related to its location. At the dorms, the topic covered will be daily life. At AC1, it'll cover vocabulary surrounding offices and appointments. In King Engineering, the topics covered will be computers and technology. At the bookstore, the vocabulary will be about purchasing and office supplies. At the visitor center, the topics will be surrounding navigation and directions. At Earhart's, it'll be food and dining. At the gym, the topic will be sports and fitness. At the DLC, it'll be classroom and academic vocabulary. And at the library, it'll surround books and coffee, since the coffee shop is there. And lastly, at STEM, the vocabulary will be about science.
EagleAR features location-based content, and those locations are used as a setting for a set of questions with a fitting theme. We are, however, unable to test this feature currently due to campus being effectively closed. The application will also feature audio to enhance gameplay. Relevant sound effects will be played when the user performs various actions, such as answering a question correctly or incorrectly. We are also considering adding background music if we have extra time, as a way of improving the user's experience with the application. Overall, audio is currently a work in progress, considering we are having some issues with importing audio files in Android, but this feature should be working within the next week. As mentioned previously, EagleAR features a point exchange feature that allows the user to gain or lose points depending on whether they answer a question correctly or incorrectly. The role of the points feature is to encourage the user as they continue to use the application, but it is not linked to the user's progress or level. The feature is currently in progress in that currently the user has the ability to answer all 4 options in a multiple choice question, but they should only be able to have 1 attempt. Additionally, the point system is eventually meant to be used for a store where users are able to spend their points for various rewards, such as extra credit on a homework assignment, and these rewards would be decided on by the professor of that course. However, its current role is simply to encourage the user's progress as they continue to use the application.
Currently, we already have a basic web application, and this web application just meets all the requirements set forth by the Apple Store and the Google Play Store for deployment. This includes having an app description, providing developer contact information, and having a privacy policy. Now this website is in progress to be moved to a Pluto server so that future teams at Embry-Riddle can access this website, but the link shown in this website is the current URL for the website.
Now we will discuss a little bit about the process of deploying a mobile application to the Google Play Store and the Apple App Store. Both Google and Apple have separate processes to go about deploying a mobile application. There's an application form associated with each that evaluates the intent and content in the application. It also provides a space to create the store listing. Each company reviews the form and the code before the listing is released on the store. These reviews typically only take 24 to 48 hours, but due to the current pandemic, those review times are being delayed to about 1 week. Also, due to current technology limitations associated with online learning, we've had to delay the process of deploying to the Apple App Store. We have an initial release on the Google Play Store that was reviewed by Google and can be downloaded to an Android device. The image on the slides is how the listing appears on the Play Store. Currently, this version of the application is not a complete prototype and cannot really be used to fulfill the design we've described in this presentation. We are working to hopefully release an update to both stores before the end of the semester with a working prototype of the application.
So now we'll talk a little bit about our test plans and the tests that we have already completed. Here's the timeline we plan to follow for testing. For each section of code, first we would test it locally in Unity, and then we would do internal testing using Unity Remote, in which we could download the code directly to our device and see if it would work on our mobile device. Once it passed that internal testing, then it will be on to acceptance testing, in which we ensure that the section of code meets the requirements it was supposed to complete. Then once that is all done, we will deploy the new section of code to either iOS or the Google Play Store. And then from there we can test it on both devices to make sure that it works properly after it's deployed. From there, we will complete user testing or beta testing on that section of code. As far as what we have been able to complete, all our code that has been deployed so far has been tested locally on Unity. There is partial testing using internal testing on the code that has been deployed after our IDR, so before spring break. All the code developed after that has not been internal tested using Unity Remote because of our lack of ability to complete internal testing with the devices that we have available to us remotely. Acceptance testing is also kind of similarly. It's harder to acceptance test and ensure that your code is meeting the correct requirements when you aren't able to physically see it on a device. So that is partially completed as well. Deployment is labeled with a dark color, that darkish blue, because it is a non-test task, but it is inserted into our timeline to show the flow. Test on device is also yellow, which means it's partially complete, because we have been unable to test post-deployment on all devices, including iOS, because we haven't been able to deploy to iOS, and Android has been a little difficult to do as well, especially with the inability to go to campus, but Marriott has been able to do some testing for us there. As far as beta testing goes, that is completely delayed, and we do not plan to complete that within the scope of our project because we are unable to go to campus to test out locations, and we aren't able to be in contact with the people that would be a part of our beta test group.
Now we will be going over the problems faced since the IDR. Here are a list of the obstacles that we have faced. Since spring break, we have not been able to have access to our resources on campus, so that has limited us to having 3 team members that have access to our development environment. Of the 3 team members, none of us had capability to test on mobile devices before our Android deployment. Another obstacle that we have run into is since we had to switch from a Mac OS to both Linux and Windows operating systems, the code worked differently. Some team members were able to see key aspects of our application, but others were not, which led to development being able to be made in certain aspects such as the map and some of the AR scene, but other aspects such as the menu, home screen, and fonts being used seem to have been broken. The next obstacle we ran into is delayed processing times for Google Play Store. Because of the COVID-19 outbreak, they had to push their times for releasing apps from 24 hours to 7 days or longer. Luckily, it didn't take that long, but we had to push deployment much earlier than we intended, which resulted in us having to push code from our IDR instead of newly updated code. The application is now available to download for Android devices, but because of our next obstacle, which is the inability to test AR scenes in Unity, the deployed application's AR scene does not work properly. Also, the inability to visit campus to test our localization has limited our progress on our map scene as well. Since our advisor, Professor Marriott, has been able to come onto campus, she has been able to test some of the map scene, but since wandering around on campus is strongly discouraged at this time, the application has not been able to be tested fully. When deploying to Google Play Store, it is strongly recommended to have a signing key when uploading new packets, but as I was trying to fix the code not working on different operating systems, the key that was uploaded for the first release has been lost, and this has stopped further uploads of our application to the Google Play Store. In order to fix this, we would have to start a whole new application on Google Play Store, which is not a feasible option for us at this time. The last obstacle we have run into is the inability to deploy to the App Store. In order to deploy to the Apple App Store, we need a computer that has the capability of holding Mac OS. Our code has to be generated from Unity, and we have to manually run it through Xcode, which is an Apple product, and then that Xcode will be translated into an application which could be uploaded to the Apple App Store. Because of the third obstacle, of which the code not working on different operating systems, the fixes applied to try to combat that has resulted in Mac OSs having different file placements for our Unity project. Because of this, the application seems to be broken, and the Apple App Store will not deploy applications even for beta testing of apps that are not end-to-end functional.
Now we'll go into talking about our project management. For managing this project, we decided to do agile development, specifically with 1-week sprints, so all the developers are assigned tasks to complete on a weekly basis. So previously, we did all our sprint planning on Sunday and used Monday through Thursday for development, and Friday was our sprint review where we went over what we did, and then we would demonstrate it to our advisor, and then we used Saturday as a buffer. But we've had to adjust that recently due to the new circumstances and working all remotely and not being in the same locations. So now we do sprint planning on Monday. We do development and daily stand-up meetings Tuesday through Thursday. On Friday, we do our sprint review and our demo with our advisor, and we now have Saturday and Sunday to use as a buffer time. In order to do repository management and task tracking, we have utilized GitLab. Now, GitLab has a lot of really cool tools, including the ability to make epic branches, regression and integration pipelines, and as well as version control and version history. In this picture, you can see a picture of our issue board that is implemented on GitLab. Now, we have tons of different boards that we move the issues through. So when an issue is created, it is put on a board that it is associated with. Typically, the board will be the name of an epic. We have some other ones that are just generalized ones for, say, this class and tasks we have to complete for this class. Once that task has been assigned, it will be moved over to in progress, where a person will be assigned to it, and they will accept it, and they will start working on it, and then they will move the issue through the board based on the status of the task currently. So once they start working on testing, the issue will be moved to testing, and then to finish, and then to closed. Now this is really nice because then we can know the current status of every task that needs to be completed at any given time. Going into spring break, we had the intention of starting to record how long each story took an individual to complete, so that we could give more complete feedback and statistics about what these stories mean. We have been having trouble doing that now with all being remote and separated and all the issues that we're encountering. It's making it really difficult to keep track of how long you're actually working on the task, when so much of this is spent trying to do things that aren't even related to your task. So that's making it really difficult to estimate how long each stories will take, but we have some statistics here for you. We, since the beginning of this project, average about 15.4 stories completed a week as a team, and that when we have estimated that one story is about 4 hours, that's what we request someone to complete. And so that's an average of 10.2 hours of work per person per week.
For the cost of development, we've had two separate types of costs. First was for licenses, one for Apple, which was $99 for a yearly subscription. Next was Android for $25, which was a one-time fee. Next were tools. The tools that we have used are Mapbox, AR Foundation, GitLab, and Unity. Some of these have premium packages that we can buy, but for our project, we have seen fit to use the free versions of all tools.
These next few slides cover some of the administrative updates and changes made and some of the constants remaining from the intermediate design review. This slide contains our abstract, a copy of which was sent to you via email. We invite you to pause the video here to give yourself a minute or two to open the abstract, look over it, before pressing play to continue on to the next slide. This slide contains our team poster, a copy of which was sent to you via email. Feel free to pause the video, take a look at our poster, give yourself a couple minutes to read over it before pressing play to continue on to the next slide. Due to outside complications that both the team and the campus are currently facing, the team has had to abruptly alter the outcome and the deliverables of this project. Given this unfortunate situation, we have been working on writing up project handoff documentation for future teams to look at so that they may continue the work we have started on this project. The documentation we are providing consists of information regarding deployment, different accounts used to publish and to develop, source code created by team members, as well as suggestions on what steps to take next. This documentation is currently in progress by team members.
Before we jump into a demo of the application, there are a few more housekeeping things that the team will be working on as the semester comes to a close. As a team, we will continue to work together to tie up the loose ends of this project. That includes final touches to development and bug fixes, as well as the finalization of the handoff documentation and any other documents that we have in progress. We also will work to deploy updates to both the Google and Apple Play stores so that the app can at least be downloaded in a prototype form for either type of device. Now we're going to show you a demonstration of the EagleAR application. The next few slides contain screen recordings of different components of the application. These are the same demo recordings that were presented in the previous design review. This is because of several limitations and challenges that this team has faced in the last few weeks. We are not able to show a current version of the application because of limitations in the personal devices and computers of the team members that are now working remotely. Even without those limitations of the physical devices, we would still not be able to run a full test or demonstration because of the location-based nature of this application. We would need to be physically on the Embry-Riddle Prescott campus in order to use the application, and that is not currently possible.
First demo is the menu navigation. First is the home screen where you will see a reminder to pay attention to your surroundings and to start the game. Once the game has started, you will end up in the map scene where you can press the menu button. There you will be able to press various options which include points, modules, badges, and settings.
In this slide, the video shows a demonstration of the application's map in use. The user's current location is indicated by the little human character. All the paths and buildings on campus are displayed, and the points of interest are indicated by the floating red text above certain buildings. As the user walks around campus, the player character moves with them.
So next, the application switches to AR mode, and an AR object, in this case a cube, appears. The AR object then starts to have a conversation with the user. The AR object then asks the user a question, and a series of buttons appear so that the user can answer. And depending on whether they answer correctly or incorrectly, the user can either gain or lose points. The user then presses the exit button on the top right of the screen so that they can return to map mode.
Thank you for attending this virtual design review for the EagleAR mobile application team. We're looking forward to your questions and feedback.